Ooh, and look, there's volume. I think after an extended struggle, we might be live for an hour. Oh my gosh, I don't know what I'm gonna do with this. Okay, well we're gonna try to do something with it, but let's hop in here and say hey, hi, while I set up a phone because we're streaming from Streamlabs, and this is the Lift and Shift Foundation and our design team, and I'll explain a little bit about that in a minute, but because I like to teach people and show people what's happening here, we have a software set up, and you can see, hi there, some streams and some cameras and things that here in this view, but for the stream that we're running today, I'm going to ditch my keyboard and my desktop, which is up there, which I'm looking at, and I'm going to use my phone, which means I'm going to use my phone, not this phone. This is an old phone, but I'm using it for a camera. There's a Streamlabs app because we're using Streamlabs, and the Streamlabs app is not the I'm going to stream live, the like in real life type thing streaming, but it's the Streamlabs button app. I forget what it's called, but they have two apps in the App Store. This one is the app that I will use to control this the stream for the day, and with it I can change some buttons, and you can see the different scenes, the different screens, and all that stuff that we have going on today. So if you are using the Streamlabs app to do things on the Twitch or the YouTube or whatever those things are, use the phone so you can ditch the keyboard. It's super helpful, super easy. I may come back to the keyboard if people start chatting in Twitch, but and I need to drop links or anything else if people want to join us. That can happen. So I'm gonna set my phone here. I'm gonna move. I'll leave the keyboard here just in case, but I'm gonna get rid of the mouse and put the mouse down low because I'm working on a tablet, and you can't. It's just out of your eyesight, so you can't see the tablet. But what you can see are some robots over here. We're gonna have a robot battle, and you can see it on Twitch up there. What else should I explain about this process? So I am the founder of the Lift and Shift Foundation. I'm also a member of our design team. What else does that mean? There's some links and some buttons and things. You can go and snoop around the website. You can just sign up if you want to find out more about the design team. If you would like to join us for a robot battle, all those things should be links now in Twitch. I think this might also be streaming on YouTube, but I'll have to check on YouTube. I don't really touch YouTube too often, so we'll dig into that just in case anybody happens to catch us on YouTube and you're looking around wondering where the buttons are. But if you're following us or tagging along on Twitch, that's should be easy to find in the About Us things. What do we do here? We mostly battle robots. On Thursday nights we do this STEM steam engine kind of thing where we share some of the behind the scenes stuff that our design team is working on. We have a design team full of veterans, volunteers who help us kind of like build the things that make the nonprofit go, and that means there's things that we can share. There's things that we can teach other people while we're doing it, and we can encourage everyone to join us because the things that look hard about science and technology are not hard at all. They're not going to keep you from they're not the barrier you think they are if you're not getting involved because you think it looks too hard. Somebody told you can't do math. I don't like math either, so we don't spend too much time on math. But that's about it. So the fun part of science and technology is doing some 3D printing, I'm making some stuff in Tinkercad, and battling these robots. So speaking of which, I mentioned this design team. I'm actually streaming. This window right here is actually a Zoom screen that I'm sharing. So I'm sharing Zoom through this phone. You can see the Zoom on the phone. You can also in the tablet. Our design team is behind me. We pin things to allow people to have their privacy if they would rather do it that way. That's cool and important to making people feel comfortable. But there's a team here, and I'm gonna drive one of these robots. I'm gonna drive one of the robots, and our design team is gonna drive the other robot for the day. And we're gonna code these robots. We're gonna program them. We're gonna have them battle right here on the Sumo map. So we have two versions of the Sumo map. We have the easy version of the Sumo map, which is a line. Check it out. It's just a line right here. That's it. It's a straight line. It's about 3 inches wide, and our robots can see this line. They have a sensor on the bottom, so they can actually catch this line, and they can do things on the line. And if they go off the line, they're losers. They'll flash their lights and maybe beep a little bit, and that's how we know that they are the loser. And for the more difficult main event later, after we've duked it out a little bit, is just a sumo circle. It's just a circle, and the same applies. There's a sensor on larger tanks robots, and they're gonna track this circle, but they're also gonna try to push each other out of the circle. And the loser goes out of the circle because they can't see the circle under them anymore, and they will also flash some lights and beep some things. But we're gonna get right into it today. We're gonna get started early. I spoke only for 6 minutes. My little soapbox is going much faster when I'm not distracted by all of the shenanigans that are going on. We worked them out earlier, but we have in the chat in our Zoom we have code from our design team. So I'm gonna work through installing the code in the robots right now, and so check it out. We're gonna grab some robots right here, and we have two robots today. We have the Future Lab robot, driven by our design team, and we have the 3D Fuel robot, driven by me today. So here they are. I am going to share some screens. We're going to switch some views here so I can show you my screens, because the code is actually set up on this tablet right here, which is just out of your view. So let me switch views. I'm going to share my screen with our design team and in Zoom and you. So let's see if that works out. That does not work out. That is not what we planned, people. Oh, I know. I do need my mouse. Because I need to remove that pin right there. Hey, look at that. Now it's all ready. Dun 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 dun. The pinning and unpinning of things in Zoom is what's gonna jam me up today, and my little pea brain is just not working very well with that. But we're gonna keep moving. So here's the boxes we use to actually do the coding right here. This is MakeBlock's website. I'm gonna open file from computer right here, and we're gonna go to desktop. Oh, there's my code right there. I'm going to open my code, which is all ready, and here it is. So this is the code that we're using for the robots today, for the robots that I'm driving today. And you can take a peek. There's blocks. It's basically just little blocks. We're going to upload it into our robot. This is the MBot right here, because we know it says it MBot right there. When the MBot core starts up, there it is. So let's get our robots going already. We're gonna go. Plug our robot in to this tablet. Dun 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 dun. USB cord plugged in. Power on. We are gonna connect. On comms 3 this time, I think it was what it looked like. Robot is connected. We're going to click the upload button. We're going to upload. You can see code is compiling Uploading. You can see some flashing lights right here if you're looking up here on the screen on my robot. Dun 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 dun. Cool. Very cool. Now you can hear the robot. You can probably hear it. It's actually following instructions. It's doing what he was just told to do. So we're gonna snap that out. We're gonna get that going. Now we're gonna set up robot number 2, the Future Labs robot. He's stickered up with the Future Lab that you can see today. He's also got some All-American stickers and things. But here's the easy part for us. We're going to go to Zoom to a chat window that you can't see on Twitch. We're going to download the code from our design team. And we're going to open it right here in our browser. So we're going to do the same thing. We're going to mash open code, open from our computer. And we're going to open that file, which I just downloaded. So now you can check it out. This is our design team's code right here, and you can see it's basically the same thing. I'm not going to chat too much about it. I'll chat in the breaks in between rounds. But we're going to connect to our robot. Connected. We're going to power the robot on just so there's no errors in memory saving files and stuff. We're going to upload. Uploading. Very cool. All right, so we've got 2 sets of code here. Ready? Now we're ready for a battle. So I'm going to stop sharing. Why? Oh, okay. We're going to stop sharing first. Here we go. We're going to go to, we're going to pin this guy here again. Go back. Oh, no, I pinned the wrong thing. The wrong place. Wrong day. There. There we go. So let's have a robot battle. Let's do this. Ready? So, hi, hey, how you doing? So, there were some things that happened here, and I'm going to give our design team a minute to reevaluate their code, but at the same time, I'm going to talk through the code that I'm using and I'm going to ask the design team here. You probably see it. I'll probably see it in the chat, but you may not see it or hear it on the stream. But there's some things that are going wrong for our robot, primarily for the 3D Fuelbot right here that I'm driving, and by driving I mean like I'm making the code. It's making all the decisions itself. We're not actually like driving like remote controls or anything. We're telling our robots how to beat the other robot with a code, just like if you play Minecraft and you've got those creepers and skeletons and stuff just wandering around. Nobody's actually playing on the other end as the creeper. The creeper just has like a code that he follows. So the code that we are building for our robot, I'm going to get into right now. So let's do the share screen thing again. Let's see if I can not butcher it this time. And here we go. We're going to switch views to the remove a pin. How about that? Dun dun dun. There it is. Okay, so let's check out this code. Let's go back to the code I was using. Let's check it out. And we're not going to save. So we're going to go back to my code right here. Check it out. I'm going to zoom in on this if I can, and I'm going to say there's some flaws here in our code. So if I can zoom in fact, I'm going to grab my fancy mouse so I can zoom in on my tablet right here without mashing my buttons. So let's check this out. So hopefully everybody can see this in the stream, but I think there's an edit we should be making here, and part of the problem is if you're up here with me on the big screen, is our robot is driving at you, and our robot is trying to make some moves on the mat, and we're using these blue blocks right here. This set of blue blocks that you can see is actually the instructions that we're using to kind of like if you ever played Madden football, and you press the circle button does like a spin move or a deep move or something, whatever you want to call it. This is basically our move, and we're just using this basic blue block that says turn left for a certain amount of time, and the time that we're doing this with is not necessarily an accurate measure here. So our robot is going off the line in that 0.05 seconds. So here's my question is, here's our design team has a new set of code. So I'm gonna delete your old code off my screen here, dude. That way I don't get confused with it. So I don't have your code anymore from the first match. And I'm gonna download your new code. But I'm also gonna take a peek here. What I'm gonna do is I'm gonna change this set of blue blocks, because we want to replace it with something called a function. So we're gonna make our own block basically. So we're gonna make a block just like that, and we're gonna call the block. What are we gonna call the block? We're gonna call the block. Let's call the block offense. Oh no, we don't want to add an input. We just want to label. And we're going to label it offense. Cool, so our block is called offense. And what we're going to do is we're going to take our blocks of code here and we're going to make it the offense. So check it out. Here's what's going to happen. When our robot gets to this spot right here, our robot is then going to run this it's called a function because it's its own little separate thing here. So now we've defined this offense, and now we can define our offense, and we can say, oh, this is actually our offense. And you'll notice right here, these parts of it are all time-based. So my problem with the time-based is, in the time that we're moving, we're going off the black line, and that means we might need to change the way we're running our offense. Instead of just like timing things and hoping the time works out on the mat, let's try something different here. Let's try we're going to keep these parts, but instead of turning left and turning right here, let's get rid of these. Let's actually drag them way far away. Nope. Let's drag them way far away in case we want to use them again. I'm not going to toss them out yet. Actually, yeah, let's toss them out. I don't want to get confusing here. I don't want to be a pack rat either. Let's try to define a real different way to do this. How else could we measure where the robot is other than time, right? Basically, we're trying to use time instead of like a position. So what we might want to ask the robot to do something until he's going off the line, for example, which actually works out really well. So we might do this repeat until here, and what we might do is have, instead of the blocks that say turn left, turn right, this robot is going to turn left. Like instead of turn left at power for 0.5 seconds, which was this was our block, we're going to replace it with something that's using the sensor. So let's try this. Let's try, where is it? Let's try turn left here. Nope. Turn left until the line sensor port detects left side being white. So basically now our robot, instead of turning left for a certain amount of time, our robot is now going to repeatedly turn left until he's almost off the line. And that's going to replace this block. So we had a couple blocks in here. We had a couple like moves back and forth. So I'm going to repeat this. I'm going to grab the mouse for this because the touchpad makes it awkward. We're going to duplicate this, and we're going to turn right until the right side detects power. So we're going to toss this, and we're going to try our new code out. And then we're gonna do the same thing again, except we're not going to use the line follower. We want to go straight. So we're going to use the onboard. Nope. The onboard. Oh, this robot doesn't have a gyroscope on it, so we can't use that. So we will use a turn. We will instead use a turn. Where is it? Right here. Nope. turn left, turn right, turn back left for 0.02 seconds, like that. So hopefully that makes him go back to the middle. And we're going to crank these up. So it's more like a an offensive move instead of like I'm backing up slowly. This is going to be a move that happens very, very fast for us, hopefully. Where what we if we're looking at this code, what we aim to see here is, I'm going to come back to my view here just for a second. Check it out. So what we hope to see here on this code now is we hope to see our robot coming at you, and when our robot is there on offense, our robot's just going to go back and forth, but in the line, instead of for like a certain amount of time, our robot's just going to stay within the line and go back and forth and keep moving forward. And it's going to look, what it should look like is if you're able to see this, what it should look like is the robot is going to do this number where it's going to shift left, right, fast, jump forward, and then move a little bit, shift left, right, move a little bit, shift left, right, move a little. So it's kind of like it's sweeping the line in front of it, and that's how we're going to keep the robot on the line, so that what we should see this time in this battle is the 3D Fuel Bot not coming off the line unless he's actually pushed off the line this time. Instead of, sometimes we've seen it last week, we saw it, he just, like made a beeline for the back wall, and that was, our time was way off. We were like turning around for like a whole second or a half a second, and it just the time-based thing didn't work out so well. So we got the robot now on a different setup, and it's not using time, but it's using the angle. We used a little bit of time, but this robot doesn't have a gyroscope. So what we might want to do for our main event is use the gyroscope and go back to 0 for the tanks, and we'll see that. So we'll test this here, and hopefully this works out well for us here. But ultimately, what might happen is, because we don't have a gyroscope, we might have to just leave this code the way it was, and we might have to put our fancy code here, our more difficult code with the function where we've defined an offense. We might have to put that in our tank robot, and we'll get to that in a minute. But what I'm going to do right now is I'm going to save this file. Let's go back to our other view. I'm going to save this file as something completely different. We're going to call it medium mbot for now. Cool, and I'm gonna save to desktop, save to computer. And we're gonna drag it away. Right down there, get rid of it so we can lose that view. Let's upload this to the 3D Fuel Bot now, since we have it open. Then we'll get our design team's code loaded up in the other bot. In the we ready? Dun 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 dun. We're gonna connect. We're connecting. You can see the lights up here if you're paying attention through more than one scene or screen. So we're going to upload this new code. with this function now. It's called a function because it's like we can use it outside of the thing, the main block of code. Sometimes it's called a subroutine because it's not part of the main block. Sometimes it's called a function. Sometimes it's called a class, depending on how we've written it. There we go. So those are the instructions, right? It's actually running the code now. We're gonna set this aside though. We're gonna put this over here. Now we're gonna go back. We're gonna open up our design team's code. We're not gonna save. Boom. This is our design team's code. So let's fire up the FutureLab bot. Get our FutureLab bot plugged in to my tablet here. Dun dun dun. Connect. Connect. There it is. We're going to upload our team's code here. Our team, you can see our team code right there. And I'm not going to get into too much of the team code other than the fact that my favorite part is the 2-second pause so I can get my hands out of the way. Compiling, uploading, things are happening. It's almost done. Done. Now, this robot, the FutureLab bot, is following code and instructions from our design team. So let me change some views here. Let me come back to me here. There we go. So we're ready for another battle. I gotta switch some scenes and screens here to make us actually ready before I move over. So let's see if I can do this right. Oh, wrong mouse. Wrong mouse. Wrong mouse. There we go. Okay, cool. So now we're back. Now we're back to the regular view, away from the screen share. And that is so weird that it's doing that. But I think I'm gonna come up with a solution for that later. So we're ready. We're ready for round 2 already. This is cool. This is big. So before we get started on round 2, I think it's important to say that I just added a fairly advanced step from the code that we've been using, and basically these 2 robots will not be operating the same way now because this robot has been using, I think it was time based and not sensor based, and now the 3D Fuel bot is actually not trying to like time things like if you're dancing and you know every beat you have to move your feet, you can time things, and that's what our robots have been doing. I have changed that now so that this robot who wants to stay in the lines, now I'm telling him that he's going to stay in the line, so he should be paying attention to the line and moving forward instead of just trying to time things, because that's a much harder thing to do. So now our robot will actually be asking these questions like, do I see white on the right or the left? Should I go back the other way? Should I sweep right, sweep left now? Should I move forward? I've done both of those, so I can move forward. And is there a bad guy in front of me? So it's using all of the sensors now, and it's checking out all the things. So we should expect that the 3D Fuel bot has an advantage here. But let's find out. Let's get into it. Ready? come back to my view here for a minute, and let's talk about this. So, I got a glass of water today. It's back to like normal temperatures here in New York City. So let's try to figure out what went right and what went wrong with this one. So first, every time this 3D fuel bot went to the left and off. So driving left. So let's take a peek at the code here. And we will terrible. Okay, so now that I'm back on my tablet, excuse me, we're gonna give the design team a break from coding here, and I'm assuming the design team doesn't want to change anything because it's worked and it's still winning. So I'm cool with that. If you don't want to change anything, I'm going to scoot up actually so I can get a better view here while we're doing this. But at the same time, let's take a peek at some of this code here. So what we can see is, let's go back to the other code. Medium mbot was what we called it. So medium mbot has this definition here, and the definition happened. That absolutely was happening. So our robot starts up. Our mbot starts up here. You can see the mbot starting. Waits 2 seconds, then forever does this loop where he's following, and as long as he's on the line, he's gonna do the offense. So let's take a peek and see what the offense actually is again. Repeat until left side. So he's turning left forever, right here. Turning left forever until the sensor detects left side being white. And then he should repeat until sensor turns left. I didn't see this part happening, which it was interesting, and I wanted to Google how to do the instant replay thing, because that would have been super helpful here to be able to go back and look at the instant replay and say this is exactly what our robot is and isn't doing. Yeah, I got you, dude. I see. So our design team gave me the update. There is no change here. There's nothing happening to update their code on their end. So we're going to take a peek here at turn left, turn right, and then turn left again. So, and then this jump forward was happening. So maybe let's try to slow things down a little bit. Let's slow down this just in case we're moving so fast that we trigger the white on both sides. That could be happening. That's an option, because we're spinning. So it's possible that there's an angle here. There's possible there's an error. So we want to go very slow so that this robot doesn't have the option of actually stepping all the way off. Because that might be what's happening here, maybe, for certain parts of this. And let's change this to 0.0. Actually, we'll leave that alone right there. We're gonna make one change at a time, and that's how we're gonna keep track of what's working and what's not working. So we're gonna upload this into our bot here. Plugged in. powered on. Connect. Upload. So the change we made was slowing down the speed that our robot turns left and right. So now we're going to run a quick extra 2 out of 3 match. Upload, 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 upload. Oh, it's almost done. There it goes. Okay, cool. Code has been uploaded. So we're going to run another quick best 2 out of 3. And this time our robot will be going slower, the 3D fuel bot. So we'll be able to see that turn left, turn right, turn left sequence. Hopefully it won't go as fast. And the only fast motion we'll see is the actual lunge forward. Well, at that block at the bottom, that block right here that says move forward at 100% power for a quarter of a second. So it should be a flash, like a jump. And yeah, so let's get it all set up. Let's check it out. Let's come back to me. There we go. Let's come back to me for a minute so I can do my unpin magic. Stop share and pin some views. We'll pin the arena cam. There we go. Okay, so let's try this again. Let's try this. This will be another match, our third match with the M-bots, these smaller robots, and this will be some updated code we're working on with the 3D fuel bot on that end. And we suggested the M-bot had an advantage last time, but given the fact that it clearly didn't work out for whatever reasons, we can't just assume this time that the M-bot's going to have the advantage. But technically it should, because he's using sensors instead of time to kind of like navigate forward. Let's try it out. Let's see what happens this time. Wait. Oh, yeah. Hi, hey. We have a little bit of time. Maybe we try that now. Maybe we change that code. Remember I mentioned that we were going to make one change at a time, and that one change was changing the speed that we saw this happen. And the speed was actually a bigger deal, right? So slowing it down, we saw that it went back and forth, and then did this like jump forward. So let's do our unpin magic here. Ready? Dun dun dun. Remove pin. Share screen. Dun dun dun. Cool. So let's check this out one last time. And if you want to change, if you want to make design team changes to the code, I'm assuming you don't at this point. This is I mean, you kind of crushed it the whole time. So I'm not so sure I would leave that, or I would change anything. But I'm going to change our code here. What I'm going to change is this block right here. We saw this happen. It clearly, the 3D Fuel Bot turned left, turned right as far as he could go on the line, sweeping each time. But at this block right here, turning back to the middle is still time-based because we don't have any other way to do that. We don't have any other actions here. You can see there are no blocks that say, there are no blocks that say sensor here. This is a light sensor, yes, so that's not helpful. This is the ultrasonic sensor that detects distances. This is the line sensor value, which is not helpful to us. This is the line sensor value there. And this is the onboard button, which is not helpful to us. The rest of this is other stuff. So, if we come back to me just for a quick second, there are ways that we can deal with this. That there are ways to handle this part of it, but that gets into more advanced coding. So we're going to leave this as it is, and try this one last time by altering our time-based code the way we have it now. So that we'll still use the time-based part to finish this sequence of moves, and we'll see how that looks for the final match between the M-bots. And what we're going to do, back to this view, is change this number right here from 0.02 to 0.05, which is what we were using last week. That was actually the number we were using last week. And I think that will put this robot almost exactly back in the center. And then we will add our blocks back. So this will be our offensive sequence. And this is basically the same kind of stuff that happens if you are like we're programming like I said, like Madden. Like if you're playing on the PlayStation and you know the circle button is a spin move. This is the code that actually happens when you push the button. And we're kind of like creating that here. So this is slightly more advanced code, and we will check out how this works for the 3D Fuel Bot right now. So let's get the 3D Fuel Bot plugged in. Step 1, plugged in. Here we go. We're going to connect with power on. Oh. Connect. Dun, 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 dun. Upload. It's compiling. Now it's sending the code to the robot because we have it connected by the wire. And that's where you can see some lights happening here. You can see some flashing and things as it's happening, but it's sending the code to the robot because we're not really driving. This robot is going to learn how to stay on that line all by himself. All right, disconnected, power off. Here we go. I'm going to save this code. I'm going to delete my medium code, my medium M-block code. We're going to save this file now. Uh-oh. There we go. Save to your computer. So we're going to save the medium M-block right there. Get rid of it. That's just our little housekeeping stuff. Cool. All right. Let's change our views here. Let's get our views all set up and changed. We will. Oh, wrong mice. Wrong mices. Stop share. Pin our arena cam. Oh, I should have gone back to me anyway. There we go. It's hard, kind of challenging to manage all these views, but we're back. We're back to the big screen here. So let's check it out. Let's have our 4th round. Best 2 out of 3. Are we ready? Let's get it. right, cool. So the 3D fuel bot lost. Done. So let's work on our main event now. Let's get away from the M bots. Let's have the tanks battle. Let's put the little guys away. Let's switch gears. Let's do the Rock'em Sock'em Robots type thing. Let's do it. So we're gonna put these guys away. They've gotten a workout, and we're gonna break out their big brothers, the big bots, the big boys. This is the Ranger tank, and here's the power cord. It uses a lot more batteries. It's bigger. It's got treads. It's got the same sensor here. It's got dual sensors here because we've kind of hacked our robot to do some things with it. And I'm not really going to get into that too much because we're already at an hour, and I don't mind going over, but it's kind of a distraction right now. But we're gonna get into the Sane Smart bot driven by our design team, and I will drive the Lift and Shift bot, which already had some batteries pop out of it. But I will drive the Lift and Shift bot. We're going to stack them right now, right here. We're also going to flip our board. So we're going to move away from the line. Our tanks, they're not going to drive on the line. They're not going to battle on the line. Our tanks are going to battle in a circle. So here's the deal. The tanks have a sensor right on the front. Both sensors are going to be stuck inside the circle. They're going to have to push each other out of the circle. So check it out. There's this little sensor right here, right in the front. So they will be halfway in the circle. They're going to have to push each other out of the circle. That's the rules for the tanks. And we're going to use the same block of code, the same file, has code for both the Ranger and the M-bot in it. So I'm going to drop the batteries in this guy right here, and then we're gonna take a peek at that code. And I've got something up my sleeve for the Ranger here, for the Lift and Shift bot, because you can see the Ranger tank has a bigger brain. Let's actually check that out. Let's take a quick peek at that while we have them both out here. So the M-bot and the Ranger. Actually, let me zoom in. Let me go back to the view here, so we can zoom in. Check. I'm giving our design team a bit of time to think about the addition that I gave in the code for the M-bot, because what I did was I actually made it much more challenging, and we've actually made it a more difficult skill level by introducing this offense function. So what I'm going to do now is I'm going to rebuild that offense function for the M-bot, or for the Ranger tank. So we're gonna switch screens. We're gonna go back into Scratch. We're gonna move some of those blocks around. We're gonna create a function or a subroutine called offense again. And well, enough of me talking about it. Let's go do it. Let's see the share screen and remove pin. da. There we go. Poof. Okay. Oh, I wonder. Do that without butchering and breaking things. That may be the view we start using, because this view is kind of old, and I like to be able to share stuff. Let me grab a glass of water, because sip of water, and let's check it out. So we've been coding in the mblock file this whole time. So let's take it over to the Ranger, and you can see the difference because up here it says when the mbot Ranger starts up. Can I move that? Oh, never mind. Okay, cool. So our Ranger here has no offense or defensive code. So let's go back and take a look at our mbot. Our mbot has this power. Wait, is this mine or yeah, this is mine. Okay. So our defense for the mbot was move backwards and turn left. Which looks a little backwards. Huh. Okay, but let's go back to our Ranger here. So our Ranger has some offense and some defense. Let's set up the defense, which is let's see. Our defense here will be move until. Actually, that will spoil some of the more advanced code, so I won't get there yet. We're gonna recreate the exact same thing that our mbot is doing, which is move backward for a quarter of a second, and then turn for a quarter of a second. So let's go back to our Ranger. Let's do the move backward for a quarter of a second, and move backward for a quarter of a second. Oh, our design team beat me done, which is cool. I'm going to download our design team file for a quick second. Bear with me. There, download it. Got you. We're going to build this out really quick. Cool. We're going to try when a line sensor port detects the left being black, which means the right is white, he needs to turn left. Okay, so yeah, he's got to turn left there. And he's got to turn right here for a quarter of a second. I think I got that right. Okay, so let's build some offense. We're going to make a block, and it's going to have a label. It's going to call offense. There. And we're going to drop our block called offense right in there. And let's drag offense over here, off to the side. So our offense is going to be almost the same as before, which was repeat until. We'll repeat that block. So repeat until sensor detects left being white. Turn left. And we'll crank up the power this time. Now we're going to reduplicate this block because it's an easy feature. And we're going to switch these to right. Cool. Now, the problem we had with our robot before was there was no, we stuck in this time-based thing, like move back to the left for a quarter of a second, but that's not cool. So what we've got here is the Ranger tank has an ultrasonic sensor. So we're going to use this ultrasonic sensor. We're going to repeat until oh no, I'm sorry, not the ultrasonic sensor. Where is the onboard gyro? Right here. So there's a gyroscope on this Ranger tank. So this big guy right here has a gyroscope, so we can tell where it's going in the X, Y, and Z axis. We're going to use that to go back to 0. And I'm gonna zoom in and show you in a minute. But we're gonna finish this block of code for our offense right here. We're gonna say until the onboard gyro axis equals 0, which should put us back at facing forward, which is where I started. Then we're going to do the same. We're going to make the same moves as before. We're going to move forward at 100%. Oh, not 400. I don't think I can do 400. For a half a second, or for a 0.25. No, back up. 0.25 seconds. So it's going to lunge forward, and then it's just going to move forward at 50% power. So we're going to see some things here. This is our offensive code right here for the lift and shift bot. So I'm gonna come back and show you this before we actually start the main event. But this is what we're looking at right now as our offensive code. So since I have this code already loaded in here and ready to go, we're gonna connect the lift and shift bot now and have the lift and shift bot get going. So there's power to the lift and shift bot. Let's plug this guy in. We're going to line them up on the back, on the table here. Plug in. Grrr. Okay. So I'm going to save this file first. We're going to call it Medium Ranger. No. We're going to save it to our computer. Right there. I'm going to drag it up onto my desktop. Okay. So let's plug in the lift and shift bot here. Plugged in. Power on. Connect. Connected. Ta-da! Upload. There it is. The code is compiling. It's compiled into an Arduino C code. It's uploading. We're sending it to the tank right now. You can see some lights flashing because we're sending this code right here to the Ranger. Very cool. Everything is uploaded. Now you can kind of hear the Ranger's ready to go. So we're going to unplug, disconnect, power off, drop our Ranger over there, we do have our design team code, so I'm going to grab our design team code right now. Let's open up our design team code. And I already saved this, so it's okay, it's cool. And here's our design team code for the Ranger. You can see our design team did some things, but it's basically all the same. They flash lights if they're off the line. So let's check this out. Let's connect the design team robot. Power on, so we don't have the problems of memory storage. Connected. Upload. Here we go. Compiling, uploading. You can see some flashing lights if you're checking out the little screen over here. And already, this tank is following instructions from the design team, because that's all robots know how to do. Cool. Okay, we are ready. We are ready for the main event. We are ready for best 2 out of 3. So what I wanted to do was give a bit of an explanation here. So bear with me for a second while we come back to me. I'm going to stop sharing, and we're going to zoom in on our arena cam. Dun, dun, dun. There we go. So I'm going to take a minute to explain this gyroscope, because this is one of the first times we're ever using it in a battle, actually. So I'm going to take a minute to explain. I'm going to zoom in on the battle. My view here. Hi, hey, how you doing? Cool. So that did not work out so well for the lifted shift bot at all today, really. Trying to incorporate new features and new ways of coding for the robot, so that it's not trying to take a guess on where he is based on time, and it's it's a learning process, obviously, as you can see. So there's a bit of testing involved here, and we've taken a few rounds to try this out. And if you caught this last week and then you caught this week, you can see last week, the very first match last week, the MBot, the 3D Fuel bot, just went straight off into the back wall, and that was it. So over the course of 2 weeks, we've had these battles here, but we've also improved some of the code so that now they're actually on the mat and they're actually doing the things that we want them to do. There's a little bit of tweaking and a little bit of testing and a little bit of seeing what works in the actual battles, and that's cool. That's the way it's kind of supposed to be. So I dig it. I think that's fun. I think it's cool. We're learning a little bit about code, so we've learned we've been introduced to this idea that we can create a function. We can kind of copy the buttons on your controllers, so that instead of us actually pressing the buttons, we're inserting the code for the buttons into the set of blocks that we already have for our robots, and that's kind of like a lot of what programming is in the real world. So it's cool. I'm glad we're like stepping up the challenge level. This is we're almost at the point where we have our medium skill level, and what you can see now, what you can kind of like see if you're paying attention or seeing the progression here, is that our robots, the MBot that we started with round one, has very basic code. You can insert a block here, a block there, and you can try things, and you can guess times and stuff. And it's not very hard. It's not very complicated. Whereas this last match we just ended with the MBot is a little more complex, because we've defined this subroutine called offense, and now we have to put some thought into, like, oh gosh, what would I do on offense? I've got this gyroscope sensor I can use. I've got this line sensor I can use, and in the future, in the coming weeks, actually next week, we have some hardware coming in so that we can actually add more sensors to the robots, and that will end up being our advanced, our like main event, and we will progress up from an easy to a medium to an advanced skill level where we maybe spend a lot of time coding the robots and having battles here that are a little more drawn out, and a little longer than 10-15 seconds, and that should be the fun part. So I'm excited to do that. I'm excited to see how we progress from following the line to actual like rock'em sock'em robots trying to knock stuff off of each other and busting each other up, because this is a really good progression from like the last 6 to 9 months of building up slowly from two robots just kind of like pushing each other around. I dig it. All right, and that's really like the end of the battle today, because we worked through 5 matches. Yeah, 5 matches, and it worked out. And I think we gotta get some new batteries for this guy here. The SaintSmart bot looked like he was dragging it. So we'll get some. Actually, we have some batteries coming in. We might test some battery power packs next week, or September-ish, because we've got some workshops coming up. But yeah, I'm excited to do that, and I will end this stream in general and sign off on Twitch today by sharing our usual highlight video. Check it out if you want to snoop around the links, find out how to get involved, how to do stuff with us. That's also around. Other than that, thank you to our design team for pitching in, being here, doing stuff. Also to people like Wounded Warrior Project and that kind of stuff. I'm gonna mash some buttons and share a video with some spelling errors on it, because I'm not the sharpest knife in the drawer. Okay.
has gone wrong.
Wally, don't do this. Don't wear Wally.
What's going wrong? No.
You know what I mean? Like, for this side. On your mark, get set, go. Point for this side. These guys.
Let's go. Have at it. Oh. Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is.
So, yeah. Oh, who got it? Who got it?
Best 2 out of 3.
3, 2, 1.
Go. Go. Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical.